Hello and welcome to another video. I'm going to go over a pull request that I made and kind of the process that I went through while making it. I've been learning a little bit of Roost recently and I decided to contribute to a project. So I'm going to walk you through what I did and why I think my pull request was successful. But anyway, let's jump into it. The project that we're going to be talking about today is a project called Git Oxide. The idea behind Git Oxide is to re-implement the Git protocol, so to speak, the things that make the file system parts and the command line parts and the wire protocol and all the things that make Git Git. Now there is another library like this called libgit2, which is implemented in C and currently is the most popular re-implementation of Git. However, if you remember from an older video of mine that I'll try and remember to link in the description, it can experience some very strange memory leaks on particular emulation situations. But anyway, that's a completely different story. But anyway, Git Oxide implements some cool stuff. I was trying to use it for a little prototype that I've been putting together, and I ran into a potential improvement that I thought might be interesting to contribute to this project itself. And so the first thing that I did while thinking of this thing to contribute was find something similar to it inside the code base. My particular proposal was to add this empty file thing, which represents a particular Git hash. In fact, you can get this Git hash by hashing dev null, which will always give you E69 and blah blah blah. This is Git's hash for the empty file. If you were to create an empty file and commit it, it will always have this blobshaw. And when working with intent to add, which depending on which order I upload these videos in, I will have already uploaded a video about that. Intent to add uses this empty blob to indicate some objects, but that's not the point of this. But anyway, I thought it would be useful to add this to Git Oxide. And Git Oxide already had a thing called empty tree, which was very similar to this empty blob, but instead it was for the empty tree. You can of course see the empty tree by doing -t tree dev null. This is the hash of the empty tree. So what I did is I started by creating an issue. Before I even started working on a pull request, I wanted to make sure that this was an idea that the maintainer would want, rather than just jumping to a solution or throwing a pull request and potentially having to go back and forth and spend a bunch of design time. And in fact, this actually saved me some time because my initial proposal was to call this empty file. However, Git doesn't really deal with files, it deals with blobs and trees. So file was a bad name. But anyway, I proposed this, noticing there was an empty tree, blah, blah, blah. I can always use this even if it's not accepted. So here's like a workaround / something else that I can do instead. And fortunately, and the maintainer saved me a bunch of time here by suggesting that instead of doing empty tree, let's call it empty blob, but otherwise sounds good. Let's make it happen. Great. So that's the first step of this. I made an issue. I confirmed with the maintainer that this was something that they would want. And we came to some agreements on what the design of this would be, such that before I even start writing any code, I know what I have to do to make this successful and to get it merged. Then I went on to try and implement this, and the maintainer also has a YouTube channel, so I haven't watched this video yet. I'm planning to watch it on stream. I might have already watched it by the time that you watch this video, but I'll link this in the description as well. But anyway, I went to go and implement this, and I did a few things here. So the first thing that I did was to try and figure out, okay, I noticed there's this empty tree. My feature is very similar to this empty tree. Let's look at how that got introduced. And so the way that I usually do this is to use git log --grep. --grep will use the commit message, or you can use -G, which will look at the contents. I think -G is actually slightly better here. And if we do this, we can see, oh, well, hold on. Let's check out before my change. Okay, git log -G empty tree. And you'll see there's a few commits that are a little bit unrelated. If we scroll down far enough, actually, if we scroll down to the very end, we should, where's the first one where it gets introduced? Let's do git log dash capital G function empty tree. That'll get us hopefully the one that we're looking for. Yeah, here we go. So this showed me another commit where this got introduced. I was able to do this and do git show and see almost exactly how this got introduced. Basically, added a function. No tests are added here, but that's kind of fine. But we have a function added here. It also told me the conventions of this repository. So this repository uses conventional commits. Personally, I think conventional commits suck, but it's not my project, so I'm gonna follow whatever they want me to do. And so it told me that if I follow this commit message structure, that probably will be better than not following it. And tests seem to be somewhat optional. I decided to go the extra mile and write a bit of tests. And so I had to figure out how the test suite worked and ran a bunch of that locally. I eventually got it working. Here's my actual implementation. You'll see it's very similar to the function that's next to it, the empty tree versus the empty blob. And then I wrote tests. Not only did I write tests for my new function, I also wrote tests for the empty tree since it was untested and very similar to what I was doing. I also learned how the low-level blobs are represented inside of Git, because my initial guess was that they're just SHA-1, so it should be the SHA-1 of the empty file, right? Well, not exactly. You can see here that this is not E69. This is something else. But what I learned is that the SHA is actually the object type. So in this case, it's blob. Then it's the length of the object. Then there's a null byte, and then it's the contents of the object. And this is how Git hashes things. So this should give us E69. And of course it doesn't. Why not? Anyway, you'll just have to trust me that that's how it is. Here, let's do it in Python. Import hashlib.sha1 blob 0 null byte. Oops, not new line, null byte. Next digest. There we go, E69. So this is how Git does hashing. There's probably an extra new line here. That's probably why it's giving me the wrong value. But anyway, that's how this does hashing. I actually did a video on Git being a database, so I will link that in the description. This is kind of a tiny extension to that. And of course, we can recover the empty tree as well by doing the same thing, but instead using tree and getting 4b82. And so I wrote some tests for that, including reusing a hasher that was already present in this particular code base. And that's kind of the summary of this pull request. So I think most of the success of this was not really around the actual code writing parts, but instead starting with an issue, deciding on a design, and learning from the previous implementation to guide how I would implement the same thing. It allowed me to get the right commit message, which the maintainer said, thank you for following the commit message thing, even though, it wasn't stated anywhere. But anyway, that's my first Roost pull request. I figured I'd walk you through it since I thought it was a little bit instructive. Hopefully you found this useful. If there are additional things you would like me to explain, leave a comment below or reach out to me on the various platforms. But thank you all for watching, and I will see you in the next one.